Here are the solutions to your spring break assignment number 3. The graphs of the derivatives. Did I even here? Let's start here at the first page, sorry. So you're given a graph and it says the graph of f is shown above in the figure. Which of the following could be the graph of the derivative? So a good first step is to draw a number line and understand, is there any turning points here? So there's a turning point somewhere between A and B. And it goes positive to negative. So there should be, wherever that is, should be an x-intercept where it goes above to below. So I see that. Nope. I don't see that. Again, it needs to go above to below. All right. And then the second part, this is concave up and then concave down. So there could be a turning point right there. I see it. And then when it goes concave down to concave up, when it changes concavity again, another turning point here where it's concave down, turning to concave up. So A is the one that matches it. Number 25. It says, what is the area of the graphs of y equals x squared, and that's y equals negative x, from 0 to 2. So y equals x squared, and then y equals negative x. And it goes from 0 to 2. That area. So the parabola, first of all, we're going to integrate. It goes x squared subtract negative x. Then I actually have to do it. So I'm going to add 1 to the exponent and divide. That's actually plus. Add 1 to the exponent and divide, and it goes from 0 to 2. When I plug in 2, I get 8 over 3. When I plug in 2, I get 4 over 2, which is 2. And then when I subtract and plug in 0, I get 0. So I'm going to get common denominators. So I'm going to multiply by 3, and I get 8 plus 6. That's 14 over 3. And there's my answer. You know you should do these first, right? All right. What is the average value? So that's an integration question from 0 to 2. I'm going to write it calculus friendly. Oops. So it's x cubed plus 1 to the 1/2. Then I'm going to see the hook. So the hook comes from inside the parentheses. So take the derivative and you get 3x squared. So I need 1/3 to adjust it. The hook is not a part of the answer. 1/3 is. And then it's x cubed plus 1. And then you add 1 to the exponent and then times the reciprocal. So I got 2 over 9. And then that goes from 0 to 2. So first I'm going to plug in 2. That's 8 plus 1. Subtract. I'm going to plug in 0. That gives me 1 to any exponent is 1, so it's just 2 over 9. So I have 18 take away 2 over 9. What did I do? None of them match. 2 over 9, 3 over 2. Wait, I know what I did. Okay, so you have 2 over 9 in it. So I actually didn't. 1 to any exponent is 1, but that's not true for 9, right? So this is the square root of 9, which is 3, and then 3 cubed is 27. This is 27. Times 2 is 54. So 54 over 9, take away 2 over 9. Now I get 52 over 9. And there's my answer. All right, I get to use a calculator now. Let f be that function and let g be that function. At what value of x do the graphs of f and g have parallel tangents? So parallel means the same, and tangent means derivative. So in other words, I'm going to take the derivative and make it equal to the other derivative and see what x equals. All right, let's see the calculator do it. So how would I do this in my calculator? I would go menu solve or algebra solve, and then I would do the derivative. And so the first one is 3e to the 2x equals, again, derivative. And the second one is 6x cubed. Very right. And then comma x. What? The derivative equaling the other derivative, and it didn't want to solve it. It didn't like it. So, you know what? Whatever. I'm going to then take the derivative old school, which is 3e to the 2x and the hook equals that derivative 18x squared, and then see if that would work. So I'm going to type that in. For some reason it didn't like it, so I'm just moving on. Menu algebra solve, and I'm going to type that in. So 3e to the 2x, move the cursor, times 2 equals 18x squared, comma x. It got the same answer. What? All right. So, oh, is there an answer here? Maybe I didn't recognize there was an answer here. I didn't move it across far enough. So I see negative 0.391. Maybe I just didn't trust moving it across. So I did see the answer. In fact, I bet it was up here too, so I didn't have to actually do it, right? Yeah, negative 0.391, it's there. All right, turn the page. So you should do it first, right? So press pause and try it. Derivative, derivative, derivative. The graphs of the derivatives are there. Which of the functions have a relative maximum? So maximum means it goes from positive to negative. So this goes positive to negative. This one does not go positive to negative. This one does not go positive to negative. So the only one that has that is f. So the answer is A. Let f be this function. So the absolute value of x looks like this. Is f continuous at 0? Yes. Can you take the derivative at 0? No, it's a corner. Is there an absolute minimum at 0? Is that the lowest point in the whole graph at 0? So the answer is 1 and 3. A can't equal 0. You're evaluating a limit. If I plug in A right now, it's 0 over 0, which is indeterminate. I could do L'Hopital's rule. So if you did L'Hopital's rule, the derivative of x squared, the derivative of 4x, and then a is some number. So whatever the derivative here, it would be 0, right? Whatever that number is. And then plug in a. So I got 2a over 4a cubed, and then reduce it down. So 2 goes into 4 2 times, and 1 take away 3, it means it here. So I get 1 over 2a squared. And there's your answer. You could also factor and cross out. So if you did that, yay, difference of squares. But you can use L'Hopital's rule and get the answer. All right, can you do calculus with a table? Can you do calculus with a graph, right? Those are good questions. So here's the table. It's continuous. Using it, what's a trapezoidal approximation of that from 2 to 8? Now, you can't do equal trapezoids because the width is different for each one. Do you see that? So each one has to be its own trapezoid. So the first trapezoid is going to be 1/2. The width is 3, and then you add the two heights. That's the pattern. Again, 1/2. The width is 2, and you add the two heights, which is 70. The next one and the last one, the width is 1, and you add it, and it's 60. And then I simplify it down. So this is 20 times 3. This is just 70, because 1/2 times 2 cross out, half of 60. So I got 160. Done. You're trying it first, right? Which of the following is an equation of the line tangent to this where the derivative of x is equal to 1? So, So let's do this. Let me take the derivative, which is 4x cubed plus 4x. That's the derivative, and I'm going to make it equal to 1 so I can see what the x value is. I'm going to use a calculator because I feel like I can't factor it. That's my gut. I see the answers that are decimal, so I go, I don't know. So I'm going to go menu algebra, solve, and I'm going to solve that. So I'm going to type in 4x cubed plus 4x equals 1, comma x. All right, I get 0.237. Then, what does y equal? So then I'm going to evaluate it at 0.237. Sure, I typed it in right. Okay, that's 0.115. And then I need to do the derivative. I hope this works. I'm going to do the derivative and plug this into the derivative. So into here, I'm going to plug 0.237. So 4 times 0.237 to the exponent 3 plus 4 times 0.237 and I get 1 or 1.001. So if I put it together, I got 1.001 x minus 0.237 plus 0.115. So I see the slope is about 1. So what would happen if I distribute that? So think of that answer as just 1. I would get 1x, and then what would happen if I went and distributed in combined like terms? So you'd have negative 0.237 plus 0.115, and you get negative 0.122. So when you distribute, you get 1x, I'm just using 1 instead of this, and then distribute and add it to 0.115, and you would get this, and now I have an answer that matches. So that answer is D. Oh man, all right, whatever. I think I put them in the wrong order when I gave them to you, but it's all good. So, we should have started here, right? But I didn't. So, whatever. 89. If G is differentiable function so that g at x is always negative, and f is the derivative here using this. Which of the following is true? So the derivative is always there. G at x is always negative, right? So x squared take away 4. To me, when x equals 2 or negative 2, then the answer is 0, and that would give you. So at negative 2 and at 2, that would make it 0 times anything is 0. So if I plug in like negative 3, it's a positive times a negative. If I plug in 0, it's a negative times a negative. And if I plug in 3, it's a positive times a negative. All right. So now this is a minimum and this is a maximum. So which one is true? So the minimum at negative 2 and a maximum at positive 2. Bingo. Was his name-o. Here we go. Number 91. Let f be a function differentiable from 1 to 10. Which of the following must be true? So if it's differentiable, that means it's continuous. So if I think f at 2 equals negative 5, I'm going to even plot it. So here, f at 2 is negative 5. That's down there. F at 5, 3, 4, 5 is 5. And f at 9 goes back here. If it's continuous, it has to at least go up and then cross down again somewhere. And so that means there's a 0 here and a 0. So there's at least 2 zeros. The graph of f has at least one, so it has to turn somewhere to go down. So that's true, that's true. For some value c from 2 to 5, f at c equals 3. So 1, 2, 3. So if it goes up to 5, at least one time, more than one, between 2 and 5, it has to equal all 3 are right. And that's done. All right, let's go back here. This should have been number 1, but you know what? We're ending with it. All good. What is the x-coordinate of the point of inflection here? So to find the point of inflection, we're going to take the derivative twice. So the first derivative, 3 times a third is 1. So it's just 1x squared. 2 times 5 is 10x. And 0, we're going to do it again. That gives me 2x plus 10 equal to 0. When I solve it, I get negative 5. And then the signs are going to change because we have an odd multiplicity. So I know there's a point of inflection at negative 5. Number 3, write it calculus friendly. And then when I integrate it, I'm going to add 1 to the exponent and divide from 1 to 2. I'm going to plug in 2 first. 2 to the negative 1 means 1/2. Subtract. Now I'm going to plug in 1. 1 to any exponent is 1, but it's negative. So I end up with negative 1/2 plus 1. So put it together, and what do you got? There it is, 1/2. Integrate from 0 to x. No derivative of that. So the integration of sine is cosine from 0 to x. Plug in x minus plug in 0. Do you know your unit circle? Cosine 0 is 1. So it's just cosine x minus 1. Here, we're going to reduce it down first. So I see a monomial on the bottom, and I see how it can simplify down. So x squared over x is just x. And this is 1 over x. The integration of x is x squared over 2. The integration of 1 over x is ln x. And then that goes from 1 to e. And then you're going to plug in e. That's e squared over 2 minus ln e is 1, so minus 1. Minus, you're going to plug in 1. That's 1/2. Ln 1 is 0. So I end up with e squared over 2 minus 1/2. So e squared over 2 minus 1/2. I got it. Number 9. I have a graph there the flow of oil through a pipeline on July is given by the graph. Well, which the total number of barrels. So total number, if this is a rate, total number is going to integrate. That day goes 0 to 24. And to do that, what do you think is the best approximation? So in other words, I want to find the area of this. So if I'm going to approximate the area, that goes like 100 times 24. And then what would this be? So think of it kind of like a triangle, right? If we're going to estimate it. So the base of the triangle goes 6 to 8. That's 12. So half of 12 times the height all the way up is 100. So to me, half of 100, 50 times 12, that's 600. So 2400 plus 600. I think this would be a good approximation, finding the area under the graph. That's how many barrels. We're almost there. Last one. F is a linear function from 0, and then what would the second derivative be? So if I integrated this, the derivative there and the derivative there, if it's a linear function, then the slope would be exactly the same. So if it's a linear function and I do the antiderivative here, derivative means slope. So the slope at every point is always exactly the same. So when I subtract it, the answer is going to be 0. All right, Mr. G, math over and out. I'm proud of you. During spring break, you're doing your work, man. Couldn't ask for more. Thank you. Until next time.